Today we are going to learn how to prove triangles congruent to each other. 4 different ways. We're going to include 2 different sections today, so it might be a little bit longer than usual. Not a whole lot. Okay, the first postulate that we're going to use is called the SSS postulate, which stands for side, side, side. So here are 2 figures of triangles that appear to be congruent, but we haven't been told that they are, so we need to use this postulate to determine if they are indeed congruent. So we're going to look at all the corresponding sides. Here is the first side. It is marked with the same congruency mark as this one over here. So yes, those 2 corresponding sides are congruent. Go to the double congruency marks. Those are corresponding sides. They are congruent. And the last one also shows that the third corresponding side is congruent. So if all 3 sides, corresponding sides, are congruent, then we can say those 2 triangles are congruent. We don't have to know anything about their angles. As long as all 3 sides are congruent, we can say that the triangles themselves are congruent. So we're finding shortcuts. Instead of having to show that all 3 angles and all 3 sides are congruent, we're finding shorter ways, easier ways to show that 2 triangles are congruent to each other. Okay, our second postulate is side, angle, side. And the order does matter. The angle has to be between the 2 sides. So notice in our diagram down here we have 2 sides and the angle that is made by those 2 sides. That is called the included angle. You need to know what that term means. Included angle. It's the angle made by the 2 sides that we're talking about. So in this case, it's not a very straight line. This is our included angle. If I use these 2 sides, it would be this angle. If I use these 2 sides, it would be this angle. Okay, so we'll be able to identify the included angle. So according to this postulate, if 2 sides and the included angle of one triangle, here we go, 2 sides, the included angle of that triangle, are congruent to 2 sides and the included angle of another triangle, so here we go. We got 2 sides and the included angle. Then the triangles are congruent. So once again, we don't need all 6 parts to be shown as congruent. If we have these 3, the side, the angle, and the side, where the angle is between the 2 sides, then we can say that these 2 angles are congruent. Our third postulate, what do you think this stands for? ASA, based on what the other 2 names were. You should figure out its angle, side, angle. Again, the positioning is important. The side has to be between the 2 angles that are marked now. So if we look down here at our figure, we have the 95-degree and the 30-degree angle, and the side between those 2 angles is also marked. So we look at our second figure, make sure that the corresponding parts are congruent. So here we have 2 corresponding angles that are both 95. Here's another pair of corresponding angles, both 30, so we're good there. And then make sure that this side between the 2 angles is congruent to the side between the 2 angles over here. Looks like we're good, so we can say that these 2 triangles are congruent to each other. Okay, so this postulate is worded like so. If 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, the triangles are congruent. So know what is meant by included side. Again, the yellow terms are terms that you need to know for your homework and for your test. The fourth one is called the AAS theorem. What does that stand for? Angle, angle, side. Yes, the positioning is important. This time we have 2 angles. It could be any 2 angles in our triangle. But the side cannot be between the two angles. It has to be one of these other sides here. For this purpose, this example, we've chosen this bottom side here to be marked. So then I look at my next figure, again making sure that my corresponding parts are indeed congruent. Our 30-degree angle is congruent. Are both sides the same corresponding side of the triangles? Yes, they are. If I had had this side over here marked, then no, we could not say that these are congruent because those are not corresponding sides. You have to make sure the corresponding parts are marked the same. Okay, so the angle-angle side theorem says if two angles and a non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, the two triangles are congruent. Notice they have to be the corresponding parts. We're always checking for corresponding parts. Notice that there is no angle side-side theorem. I should not see this answer on any of your papers. Okay, so now let's do a couple of examples and see if we can figure out which one of those theorems allows us to say that the two triangles are congruent. And sometimes we can't say. So here's two triangles sharing a side. Okay, there's actually a couple of ways we could say that these two triangles are congruent to each other. Let's look at what is marked. I have a side, I have another side, and I have an angle. So I have three parts, a side, and an angle. Now, where is that angle? Is it between the two sides? It is. So we need to put those letters in the same order as they appear in the triangle. Is that one of our four theorems? Yes, it is. So we just need to make sure that the same corresponding parts are marked on this second triangle. And if so, then we can use this theorem to say that yes, these two triangles are congruent to each other. And it looks like we do have the same corresponding parts. What would be another one of the new theorems we just learned that we could use to say these two triangles are equal to each other? We don't have anything else marked congruent besides two sides and an angle. But do we know that another part might be congruent just by the way the figure is drawn? If they share a side, almost always we can say that that side is congruent to itself and use that idea. We can always say it's congruent to itself. We just may not need to use that. But almost always, if they're sharing a side, you're going to use that side to figure out the answer. So now I have three sides of both triangles marked the same way, and they're corresponding, so I could use the theorem side, side, side as well. Either one of these could be used to prove that these two triangles are congruent. Let's try another one. Okay, what about this picture? We don't have any angles marked. So we got to ask ourselves, is there any way to say that any of these angles are congruent to each other? For example, what if I had something like this, where I had parallel lines being cut by transversals? Okay, I could say that these two angles were congruent to each other because they're alternate interior angles. And I could say that these two are congruent to each other, even though I didn't draw them congruent at all. Okay, so we're looking for situations like this, but we don't know that any of these sides are parallel. So there's no angles. We don't have any vertical angles. We don't have anything that tells us any of these angles are congruent. But I do have some congruency marks on my corresponding sides. So I have two sides. But I got to have three parts that are marked congruent? I can't find any angles. So the only other option is a third side. Here's my third side. Remember what I just said in the previous example? If they share a side, 9 times out of 10, you're going to use that. So yes, this third side is congruent to itself. Therefore, I can say all 3 sides of the left triangle are congruent to the 3 corresponding sides over here in the right triangle. Therefore, I'm going to use the side, side, side theorem. One more. Okay, let's think of all the different ways that we can say that these 2 triangles are congruent. And then we're going to write our congruency statement, remembering how to match the corresponding parts. So the first thing I see right off the bat is that I have all 3 sides that are marked. Are they corresponding? These 2 are corresponding. Again, it says if we took these 2 triangles and laid them on top of each other, would these 2 parts match? They have to match and be congruent. So yes, that's good. What about the ones that are marked with 3 congruency marks? Are they corresponding sides? Do they match? Yes, they do. And then what about the ones with the 2 congruency marks? They match as well. So we could say side, side, side. That's one option. I got some angles marked in here. What are our theorems that have angles in it? We had angle, side, angle, and we had angle, angle, side. So let's look and see if we could use either one of these. Here's my 2 angles. Are the ones marked the same corresponding? Here's 2, 2. Yes, they match up. 1, 1. Yes, they match up. So I have 2 angles and I have a side in between them. So yes, I can use this one. Can I use 2 angles and a side that's not between the 2 angles? Well, I can use this side or I could use this side because both of them have their corresponding parts congruent over on the other triangle. So I could use this one as well. So 3 possibilities here. 3 different theorems that allow us to say that these 2 triangles are congruent. Okay, now let's write a congruency statement. Remember, it does not matter how I name my first triangle. I'm going to name it triangle CAB. And I can now say that it is congruent to triangle what? I have to put the corresponding parts in the same order. So if I started with C in this triangle here, I have to start with the same corresponding part in the second triangle, which just happens to be named C as well. Now if I go to A, what's the corresponding part to A over here? It would be D. And then I go up to B. The corresponding part in the second triangle is E. And there's my congruency statement. Okay, so be able to determine if 2 triangles are congruent. Be able to tell me why. Which of the 4 theorems, what am I missing here? Here's 3 of my theorems. Can you tell which one's missing? Side, angle, side. So be able to tell me which one of these theorems allows you to say that these 2 triangles are congruent, and then be able to write your congruency statement, matching your corresponding parts in your name. And that is it for today's lesson.